Welcome back. This is Dr. Me at the Actuarial Academy, and we're off to work another actuarial problem. And this one's actually modeled after one of the problems on an actuarial test. A school receives 1/4 of its shipment of pencils from Company A and the remainder of its shipments from other companies. Each shipment contains a large number of pencils, and Company's A shipments contain 4% defective pencils, and for the other companies 2% are defective. And after a shipment of pencils arrive, the school tests 20 randomly selected pencils and finds that 2 are defective. What's the probability that the shipment came from Company A? Okay, so this problem does involve several concepts. It involves command of the binomial random variable and conditional probability, and it also requires you to have knowledge of Bayes' theorem. So we'll kind of mix that in as we go over this problem. But just as a quick review here, we do have a couple of facts that if x is distributed binomial with parameters in p, then the probability that x is equal to k is actually given by this probability mass function you see right here. And also conditional probability. This is a definition. The probability of A given B is equal to the probability of A intersect B over the probability of B. And so these are the facts that we're going to have to use. But let's just make sure we understand the actual problem. So a school receives shipments, and these shipments are at least of size 20. Okay, let's just go ahead and assume that. And typically 4% of these shipments of pencils are defective from Company A, and 2% are defective from all the other companies. So after they receive a shipment, they actually test 20 randomly selected pencils and finds that 2 are defective, and we'd like to know what's the probability that a shipment actually came from A. So let's define some events here. It's always important to have some foundation here, define some events. And let's define A as the shipment came from Company A. And let's define another event, O, to equal the shipment came from another company. Alright, we need to have one more event defined, and we'll designate that as D. And here, D is 2 pencils from a sample of 20 are defective. Put that in there, squeeze that in there, so we'll just leave it that way, are defective. Alright, so now we're set up to solve our problems that we've defined our events. And what we're looking for here is, again, the observe 2 defective pencils out of a sample of 20, and what's the probability that the shipment came from A? So it either could come from A or from B, right? So what we're looking for overall, we can go ahead and write that down, at least in math terms, is we're looking for the probability of A given D. Okay, what's the probability the shipment came from A given that 2 pencils from that sample, or sorry, from a sample of 20 are defective? We'd like to know it actually came from A. Alright, now we can use our conditional probability here. This is equal to the probability of A intersect D, all divided by the probability of D. Now, using another rule, actually, but we can rewrite this statement, probability of A and D, as the probability. So I'm going to do a little switch here. We're looking for the probability A given D, but we can rewrite probability of A intersect D, what I have here in the numerator, as the probability of D given A times the probability of A. And you'll see why we're doing this in a moment. This is essentially Bayes' theorem at play here. We're going to leave that probability of D, because we're trying to cast what we're looking for into expressions that we know. So if you look at this, you'll see why I did this. Probability of D, that's the probability that 2 pencils from a sample of 20 are defective, given the shipment came from company A. Okay, so we're going to work this out piece by piece, in that we're going to first compute the numerator, and then we're going to compute the denominator. So we'll do that in a different color. Let's choose blue. Right, and we're just going to look at the numerator here. Probability of D given A times the probability of A. Just work out that piece there. So first we need to compute probability D given A. So if the shipment is from company A, then we like to compute the probability of observing 2 pencils that are defective from a sample of 20. And this is where the binomial random variable comes into play. So this would be 20 out of a shipment of 20. We'd like to observe exactly 2 defective, and since it's coming from company A, we notice that they're actually 4% defective. So this would be 4%. Raise it to the power 2 times the complement, 0.96 to the 18th power. And so this takes care of probability D given A. And again, if you're not familiar with the binomial random variable, please review it, and if you'd like me to do a video, just let me know. I can review that. And then times the probability of A, which is the probability that the school actually got a shipment from A, and that is 0.25 or 1/4. So then we need to include this piece here. So that takes care of the numerator. Okay, let me just separate this out a little bit so we don't confuse that with what's above. Now let's compute the denominator, probability of D. That's just the probability of observing 2 pencils being defective from a sample of 20. Okay, independent or without regard to where it actually came from. It's just just randomly selecting a shipment and then observing 2 defective, and that's what's in the denominator here. And I do have a video on Bayes' theorem and the total law of probability, which I recommend you watch. It goes into detail on these computations, but here we're going to actually use the total law of probability, where we condition on another event. So to actually compute the probability of D, we would need the probability of D given A times the probability of A. Now notice we've already computed this, so that's nice. But we also need to weigh the probability if the shipment came from the other company. Okay, and so this is equal to precisely what we already have right there, so I'll just indicate that with star. Okay, where star is up here, and plus, now we just need to compute this piece here, probability of D given it came from another company, and this is very similar to what we have up there. It's still 20 choose 2, but our probabilities have changed. Since it came from another company, 2% are defective, so this would be 0, 0, 2 raised to the 2nd power times 0.98 to the 18th power, and then times the probability it came from another company. Well, 1/4 of them comes from A, and the remainder come from the other company. Okay, so we're almost done. We have all the pieces we need for the probability of A given D. And let me switch that back now. And so this would just be the probability of A given D then would just be equal to everything in the numerator here divided by what we've already computed down here. And if you work this out, this actually equals 0.5 479 146. Okay, so this was basically an exercise in knowing how to use conditional probability, knowing how to use a binomial random variable, and an exercise in Bayes' theorem and total law of probability. Thank you very much.